Another week of Wade work. So I've done some more problems, slogging through chapter 5 problems, finished section 5.1 and 5.2 integrals. I'm taking my time, so I think this week and next week will be chapter 5 problems. And I'm right through the middle of chapter 5, section 3 problems. A little stuck on one problem. Actually really stuck, but I make it a policy of mine for some problems, even in the reading cycle. Now this is the second time that I'm doing it, to just do it. Just take the time to figure out. There's always a trick, something that leads to a lot of learning, and I don't want to waste that opportunity by looking up the answer, looking up more handouts on the web. I don't think this is one of those. I think I'm going to really take my time. It's all about the derivative of x to the q being q times x to the q minus 1. And you got to use that for rationals to prove that the log of x to the q is q times the log. Seems simple, and I've already worked out on a previous problem that was in this theme. But I've kicked myself around early this morning trying to figure this out. It just didn't work out, so I'll give it tomorrow morning with a new fresh mind. I'm also deep into chapter 7 reading, so I'm in section 7.2. Yeah, I think so. Yeah, I finished up to here. So I'm when I do reading again, I'm going to be reading about power series. So that's my reading progress. Even though I'll be talking about chapter 7 once I get around to it, I will mention, interestingly, that the book discussed a proof, and if I don't find it right now, I'm not going to waste anybody's time in doing so, but it was the changing the order of summation. And so that worked out very interesting because Wade quotes Rudin, but actually Rudin did a better job, in my opinion. So I had to actually read Wade and read Rudin for the same proof, and that was interesting. I always like to do that, get two different perspectives, even though it's technically the same proof because Wade referenced Rudin, with permission even. Anyways, so working through chapter 5 problems, and of course, all of next week, I will read a little less to do a little more problems. This is integration. I know it's the core. It's got to be done. There's no easy, quick way to do it. Then for reading, of course, section 7.2 completed. So yeah, making progress. I think I'm about a third, almost a halfway by section, but not by number of pages. By number of pages, I'm here, and so I'm kind of like a third through the book. Then I marked where I last left off, and it's mostly really just chapter 5 problems. Snagged a few handouts off the interwebs, and that's okay. Bulks of the book, but I like to keep the handouts. I go back and I look at them as I make progress. So yeah, worked out some problems. Looked at Thomae's function, which is f of x is equal to 1 over q when x is equal to p over q, and then 0 when x is irrational. Very interesting properties. Use ChatGPT. So it's a nowhere continuous function that is Riemann integral. That's the thing about Riemann integrable. I have to say that correctly. There were some interesting other proofs for Thomae's function off of Wikipedia, so I took that. Then I kept going with more problems, more interesting problems, all about, and of course, continuity limits. They just keep coming back. Continuity limits. Even when you do differentiation, when you do integration, you're always going back to all these different rules of what is continuous, what is differentiable. Is it uniformly continuous? Is it uniformly differentiable? So yeah, all those rules. And every now and then, a question, even an integration, will go all the way back to a limit proof for parts of it. some simple integrals with absolute values. Yeah, just more simple, the simpler part of integration at the beginning of the chapter. Of course, x to the n, very interesting. I still want to do that Desmos video, I just haven't had time of plotting x to the n in Desmos, and you see that from 0 to 1, it just becomes an inverted L, and so of course the integral is 0 there, because it really is just 0, except at the very end when it goes to 1 for like x to the 100 or something. Yeah, more integration. Slow going, as would happen with problems. Found a great handout. Went deep on the whole antiderivative big F prime definition. These d over dt integrals. Examples such as, got this handout, such as d of dx of 3x sine t squared. The key there is that you're actually evaluating the function, and because you're evaluating the function and eventually you're going to do a derivative, if it's a constant, if one of the limits is a constant, it's 0. So it's really evaluating at. And there's also a chain rule that there's a little bit of a chain rule trick that has to be used. So I had never done that type of problem, so I went a little deep on it just to make sure that I understood it, and I think I do, and I worked out those problems in the book. And then I'm stuck on something that seems simple, and I'm sure when I look it up, I'm going to realize how stupid I was. But I don't want to look it up. I don't want to do ChatGPT on it. Nothing. I'm going to just beat my head, and I think the learning experience should help me. And then, of course, eventually I'm going to load these up in the notebooks. All of Chapter 6 reading, Sections 7.1 and 7.2 reading. So that is my progress for this week. Wish me luck in figuring out that problem that's kicking my butt.